Let's draw the influence line for the point M. M point is right where the given moment is, and external moment, and it's from the point C 1.5 meters. Actually, it's in the middle. Yeah, it will be interesting how it would look like when there's no in the middle. It just moved like 1 meter, like for example 1 meter from the point C, so it will move a bit. It will move. It will be a bit more complicated, but that's okay. Okay, let's draw it for the shear force U for the point M. It's in the very middle. Influence line. That's a case 2 for the shear force and the bending moment rules. Case 2 is a bit easier. At both supports of the short span, sometimes it's hard to recognize where it is like mid-span and where it's cantilever part. This one, that's for the next examples. Okay, so if there's 1.5, no, I was mixing with the bending moment, the influence line. Okay, about the shear force influence line. So we should make this base system standard shear influence line element. It's like always with dash line, actually. Always like this, positive left side and negative right side. So it's positive 1 and this is negative 1. With the dash lines. And we go till the we can make this standard element with the dash line. But where the R cut the section is, we cut it, and the triangles that lays close to the beam, we draw with a solid line. And case 2 goes to both sides, especially for this beam free body diagram. So at the hinge, it turns the direction and ends at this end support, and to other side as well. It's here, turns the direction and go through 0 at the support and just finish at the end. Actually, it's pretty similar as we had before. It's like this. And also the answer will be the same, but I found a mistake that there's -10, so there's negative for M. Comment if you know the answer. I just verify with the answers for diagrams in a normal way with the static equations. There should be -22.5. 22, or how it looks now, it's 27.5. Yeah, but it looks like this, and nothing changes in between. Yeah, it's the same. So I will not calculate, I think. Yeah, but the bending moment, let's draw that. M at the point M, influence line, and we can read the rules here. You can stop the video and end the rule. Read the rules. Yeah. So plot downward. Always start downward with the picture like this. And how much down? We are. This point M is here in the middle, and it's 1.5 meters from one side and 1.5 meters to another side. So we draw with the dash lines, actually, 1.5. It can be drawn in 45 degrees. And there is the butterfly. And the intersection should be right under the point M. The middle point, because we know that's 1.5 and this is 1.5, so in the middle it will be half of it, 0.75. The real, so these are dashed lines. The solid line is the triangle that lays close to the beam. We can redraw it and continue to both sides, as it is for the KAs too, and the rest two general rules, as well as here to other side. Actually, these sides are equal, almost. If there would be cantilever overhanged part, then it will go the same, but it stops at the support. Okay, now it's a bit more interesting to calculate. This is 0.75 because the distances are the same. You need this triangle because it's right under the distributed load. So, and now we can calculate the area of this 0.75 times 5/2. 1.87. In Latvia, we use comma, and that's negative because the signs are opposite as shear force. Positive down, and we need this y ordinate. That's 1.5/3, and this is 2 meter. I bet it's 1. 3 meter, yeah, it's 1. 1/2. That's 0.75, looks like. And we can calculate m value of at the point M. But that's actually pretty like special significant point, because there are two values of moment. There will be jump of 30, comparing to the verifying the results should be plus 1125 and minus 1875. How can we get them? So we find one is left side and one is right side. Oh, but okay, we can do it a bit later. So first there will be plus p times 0.75 and negative q times area 1.875. And then there will be two values of m times tangents. And tangents, there's this angle. Actually, it's so the angle, we can use this angle or this angle, they are equal. To the left, to the right. Okay, so 1.5/3. Now we use both signs. So p equals 20. 15 minus 6 times 875, 1125, and then there is two values of m 1/2 of 30, so 15. Let's spread it. One is which one? So to the right, it was positive 1135. Positive. Yeah, by comparing these two, we can find the mistakes, like also in diagrams. So I found, and so from left side it's negative 1125. Now I'm sure. So from left, okay, minus 5, the left value, and my positive 30 minus 1125, it's plus 1875. Right, from the right side. So these were influence lines for the midspan. Yeah, like shorter, but for this free body diagram, it's for both sides, it goes very far.